All right, let's talk about one of the most famous charts in all of science, the periodic table. You've all seen it, right? But the story of how it came to be is just incredible. It's a tale about turning total chaos into elegant order, with a little bit of music and a whole lot of genius. So let me start with a question that sounds like the beginning of a bad joke. What in the world do music and chemistry have in common? Well, it turns out the answer is actually a key part of our story, a really creative, even if slightly flawed step towards organizing the very building blocks of our universe.
To really appreciate just how big a deal the periodic table was, we have to go back in time. Let's set the scene. It's the middle of the 19th century, and the world of chemistry was, to put it mildly, a bit of a mess. By the 1860s, scientists had found over 60 different chemical elements. Think about that, more than 60 unique ingredients that make up everything. But they were basically just a long, disorganized list. There was no rhyme or reason to it, just a pile of discoveries.
You know, imagine trying to bake a cake, but all your ingredients are in unlabeled jars all over the kitchen. That's pretty much the challenge chemists were facing. They knew that some elements acted alike, but finding an overarching pattern felt next to impossible. They were desperate for a system, any system, to make sense of it all.
And this is where our story gets really interesting. The first serious attempt to solve this puzzle came from a place you would never expect. An English chemist named John Newlands looked at this elemental chaos, and he heard music.
Now, Newlands actually had a musical background, and when he started arranging the elements by their atomic weight, he saw something incredible. He noticed a repeating pattern, and he called it the rule of octaves.
His logic was actually pretty elegant. Think about a musical scale. The eighth note is basically the same as the first, just an octave higher. Newlands thought the elements worked the same way. He proposed that the eighth element on his list was a kind of chemical repeat of the first, sharing similar properties. The ninth repeated the second, and so on. Pretty cool idea, right?
So he came up with this rule in 1862, and a couple of years later, he presented his big idea to the top chemists in the world at the Chemical Society of London. He must have thought he was about to change everything.
Yeah, it didn't exactly go over well. In fact, he was pretty much laughed out of the room. The scientific community thought his musical analogy was just plain silly and rejected his theory. And to be fair, they had some pretty good reasons to be skeptical.
See, the problem was, once you got past the first couple of octaves, his system fell apart completely. It started forcing some really bizarre pairings. For instance, his table said that iron, a solid metal, should be in the same family as oxygen, a gas, or that phosphorus should behave like manganese. Any chemist knew that was just flat out wrong. The music was completely out of tune.
So Newlands' musical idea was a fascinating attempt, but ultimately a dead end. But he did plant a crucial seed, this idea of periodicity, of a repeating pattern. Now, let's bring in the man who would take that seed and grow it into the masterpiece we know today, the Russian chemist Dmitri Mendeleev.
Now, other people were working on this problem, but Mendeleev is rightly called the father of the modern periodic table. He started from a similar place as Newlands, but he brought a level of discipline and, frankly, an almost psychic insight that no one else had.
His method was way more systematic. Sure, he started by listing the elements by atomic weight, but then he organized them into a grid, with horizontal rows he called periods and vertical columns he called groups. And here was his ironclad rule. Elements with similar properties had to be in the same group, no exceptions. And if something didn't fit, well, this is where the genius part really kicks in.
This is honestly the part of the story that still gives scientists chills, because Mendeleev didn't just organize what was known. He literally made room for things that were completely unknown.
Okay, just look at this simplified piece of his table. He sees silicon followed by phosphorus. Then down in the next row, there's arsenic. Based on the patterns of weight and properties, he just knew there had to be an element that fit right here, under silicon. But it hadn't been discovered. So what did he do? He did this. He left a blank space. This wasn't a mistake. It wasn't him admitting he didn't know something. It was an incredibly bold prediction. He was basically pointing at his chart and telling the entire scientific community, there's an element that goes here. Go find it.
And that was his true genius, and it came in two parts. First, just having the guts to leave those empty spaces. But second, and this is the incredible part, he used the patterns in his table to predict the properties of these missing elements. He described their atomic weight, their density, even what their chemical reactions would be.
And guess what? He was right. His predictions were shockingly accurate, and because of that, his table wasn't just a reference chart anymore, it became a treasure map. It literally guided chemists, telling them what to look for and where to look for it. They went out, found these elements, and every single discovery proved that Mendeleev's system was profoundly right.
The story of Mendeleev is such a powerful reminder that sometimes the biggest breakthroughs aren't about discovering something totally new, but about finding the hidden logic, the beautiful pattern in the things we already know. It really makes you wonder, doesn't it? What other elegant patterns are out there all around us, just waiting for someone to finally see them?